We're going to be kind of introing, reviewing inequalities because I think you guys might be a little bit rusty from 6th grade. And I just want to make sure we have a nice solid foundation on this before we start talking about two-step inequalities. Okay. So our learning target today is I can understand, write, and graph simple inequalities. Okay. So before we can do all those things, though, we really need to make sure that we understand what an inequality is. So I'm going to write the definition for that here. Okay. So inequality what it does is it compares two expressions using these symbols: less than, greater than, less than or equal to, or greater than or equal to. Hopefully those symbols are familiar to you guys. You're good on that? You've seen these before? I imagine so, because they start introducing these, I think, in like 2nd grade, because my 2nd grader does some inequality stuff. Okay. Now I want to make sure we're clear on what these symbols mean. So I'm going to set up a little chart in my notes. Yours does not need to be perfect and neat. I'm just going to use a ruler though on mine to make sure that the notes are readable and useful for you guys to understand. Okay, so we're going to be discussing 3 things. I'm going to show you what the symbol is. We're going to talk about the meaning of it. And some word phrases that you're going to see when you're looking at word problems to help you know what symbol to use. Okay, so those 4 symbols that we're going to be talking about are right here. We have less than, greater than, less than or equal to, and greater than or equal to. Now I'm going to go ahead and write the meaning down here. This is just going to help you to remember what each symbol means. We read this symbol, we say is less than. Oops, hold on. Okay. So when you see that symbol, that is less than. And some phrases that you're going to read to help you to know that it's less than are fewer than, below, okay? And we might add some more to that list as we're working through problems. This next symbol we would read as is greater than. And some common phrases that you might see when you're reading word problems is more than or above. Okay. The next symbol is read like this. We would say is less than or equal to. Okay. So it could be both. It could be less than, or it can also be equal to. So there's a distinction there between this symbol and this symbol, because this one cannot be equal to. Some common phrases that you might see are at most or no more than. The next symbol is read is greater than or equal to. And some common symbols here, or some common phrases that you're going to see to indicate this symbol would be at least or no less than. Okay, so what we're going to do now is we're going to write inequalities based on some situations. So for this one, we're going to write an inequality for each situation. Okay. So the first situation that we're going to look at, the capacity of an elevator is at least, or sorry, not at least, at most 12 people. Okay, so my question for you is, can it be 12 people? Yeah. And anything less than 12, right? Okay. So let's get our variable going on here. I'm going to quickly be defining my variables off to the side here. I'm going to use C for the capacity of the elevator. So I'm just going to say C equals the capacity. Okay. Now, C being the number of people in the elevator, we already talked about it. It can be less than 12 or it can be equal to 12. So we're going to use this less than or equal to symbol, and we're going to say 12. Okay. And the key phrase here was at most, which you can see right here, and that's an indicator of using that less than or equal to symbol. Okay. Let's do one more like this, and then I'll have you guys try a couple. There are more than 1,000 books in the library. Okay. Now, can there be 1,000 books in the library?
Yes.
It says there are more than 1,000. So I would actually say no, because it clearly says that it's going to be more than 1,000. So we wouldn't have 1,000 books in there. So we're not going to use one of these symbols that's equal to because we need it to be more than 1,000. And more than, our key phrase here, indicates that we're going to use the greater than symbol. So I'm going to let I'll let B equal the number of books. And for this one, it says that it's more than, so I'm going to use that greater than symbol. So we're saying the number of books in the library, B, is greater than 1,000. Okay. So let's go ahead and have you guys practice with 2 quick ones, and then I'm going to show you how to graph these. So here's the first one. All right, so go ahead and write inequalities for those real quick. I'm going to define my variables. It's okay if you use different variables than me. All right, somebody want to tell me what they got for number 1? Go ahead, Rhea. So you said P is less than or equal to 60? Yeah, good, because there can be no more, but there can be 60. No more than 60. Let's see, number 2. Go ahead, Ishan.
T is more than 72 degrees Fahrenheit.
Awesome. Because it says that it's above 72. It does not say that it can be 72. Any questions for me before we move on to graphing? All right, then flip those pages over. Or you might not need to. I need to, though, so I'm going to flip mine over. All right, so before we get into graphing, I want to talk about the solution set, because when we're graphing inequalities, we are graphing the solution set, okay, because there is a range of solutions to each one of these inequality problems. So a solution set is all of the solutions of an inequality. Okay. So that could be like, so let me actually put an example up and we're going to talk about it. So we're going to graph each inequality. Okay, and let's take a look at this first one. We're going to say that x is greater than -4. Okay, well, if you look at my number line up here, my wand, okay, -4 is right here on the number line. And this is not an equal to one, so we would say that -4 is not actually a solution. You can't plug in -4 for x, because -4 is not greater than -4. But -3 is greater than -4. -2, -1, 0, 1, 2, 3, and so on. These are all greater than -4, okay? The other things that are greater than -4 are all of the fractions and decimals in between. Because all the way up until -4, these are all going to be solutions over here. So I could say -3.999999 on infinitely would be a solution to this, because it's greater than -4, okay? So when we are talking about that solution set, we tend to show it as a graph, because it's such a wide range of numbers that are solutions. The best way to see the solution set is to just put it on a number line. And the way that I like to graph is I just put whatever number I'm dealing with right in the middle. I fill in the number line a little bit to the left. I fill in the number line a little bit to the right. And then I do my graphing. Well, we already talked about it, but a -4 cannot be a solution to this. It is not greater than or equal to. It has to be greater than. So the way that we show this when we're graphing is a hollow circle. This tells us that -4 is not actually a solution. Okay, so we leave that hollow so that it's not filled in as a solution. And then we shade everything that is a solution. So everything to the right here is going to be a solution to this. Okay, 0 is greater than -4, -1 is greater than -4, and everything in between those whole numbers or integers are also solutions. So we just shade it all, okay? So that's what that graph looks like. The next one that I'm going to show you, we have 1.5 is greater than or equal to m. Okay, so I'm going to put 1.5 right in the middle of my number line. I'm going to fill it in either way so you can see. Okay, mine aren't perfectly spaced out. Okay, now in this case, can 1.5 be a solution? Yeah, because it's equal to, right? So the way that we show that when 1.5 can be a solution is we fill in a solid circle on our number line. That shows us that 1.5 can be a solution. And now we need to figure out which side to shade. So let's test it out, okay? What I like to do is I like to just pick something on either side and see if it makes this true. If it makes this true, then that's the side we're going to shade. So I'm going to just plug in, so 1.5 is greater than or equal to -1. Is that true? Is that a true statement? Yes, it is. So that means I'm going to be shading the left side of my circle here, okay? Now, what would happen if it was not true? So let me show you if it was not true. If I had plugged in 3 here, so 1.5 is greater than or equal to 3. Is this true? No. So if it's not true, then that is not the side you're going to be shading, okay? Does that make sense? All right, well, I was going to have you practice this, but your homework will give you some practice. Now, you might be wondering about your homework because the inequality symbols are hard to find because you have to use the equation tool. And you also can't show your graphs on the homework either. So don't worry about typing your answers into Otis tonight. Just do it on paper. And I'll check in your homework using Class Dojo on Monday, okay? So you only need to do your homework on paper this weekend. And if you finish your iReady assessment early and you don't have anything to do, you can do your homework so that you don't have homework over the weekend, okay? All right, you guys can pack up. I will see you next week. Oh, if you finished under a minute this week for your thatquiz.org, come see me. I have some candy for you.